Okay, so for this example in your textbook, I'm going to walk you through how to do number 32. So this is your Poisson distribution. Notice they tell you in the problem, it says mu is equal to 4. And so I put a picture of your appendix probability distributions for Poisson at the bottom here. So I just located the mu value where mu is equal to 4, which is right there. And the first for part A, it says, what is the probability that x is equal to 2? So I find where x is equal to 2, which is right there. And then I go where it intersects, and the answer is going to be 0.1465. That's all you have to do. Now, on part B, it says, what is the probability that x is less than or equal to 2? So in that case, you simply go to the same area in the table and locate 4. I want less than or equal to 2. That's going to be 0 plus 1 plus 2. So to get basically 0, 1, and 2, you'd take 0.0183, you'd add 0.0733 plus 0.1465, and that would basically give you your probability from 2 or less. All right. Now, the last one then says, okay, what if we want the probability that x is greater than 2? So now we're going to go the other way. So the way you're going to do that one is I go to my area under the table in the probability table. I'm still at 4, and so more than 2 is basically going to be 3 through infinity. And so the way you want to do this one is to simply take 1 minus 0.0183 minus 0.0733 minus 0.1465. So that's going to give you essentially, I'm going to draw a line right there, 3 to infinity. So the way, anytime you get a question asked, like you want to go greater than or equal to, you're going to have to do a 1 minus type of calculation to get the cumulative probability. Because remember, with Poisson, x theoretically keeps going, and so you can't keep adding them. You just have to find, in this case, 0, 1, and 2, and then subtract those from 1 to get the cumulative probability. Okay, so for this Poisson one, this is going to be number 35. So in this one, it says, it is estimated that 0.5% of callers to the customer service department of Dell will receive a busy signal. What is the probability that of today's 1,200 callers? So first of all, you have to get a mu or expected value. So if you took 0.5%, which is 0.005, and multiplied that by 1,200, you would get 6. So that would be your expected value based on this percentages. And then the question they're wanting is what is the probability that at least 5 would receive a busy signal? So at least 5 is like saying the probability that x is greater than or equal to 5. So I go to my Poisson table, I locate where mu is equal to 6, and I want 5 or more. So here's where my 5 or more starts right there. So quite literally what you're going to have to do, I'm going to circle these first ones, you're going to take 1 minus 0.0025 minus 0.0149 minus 0.0446 minus 0.0892 minus 0.1339, and that'll give you the cumulative probability of 5 or more. So again, that's how you would use the Poisson table to get this cumulative probability.